This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited. Any information provided through BURSI is not to be used as a substitute for professional engineering, design, and/or documentation required by building code, contract, or applicable law.
We're going to be talking about when the membrane stops and talk about expansion joint covers and edge metal solutions for your roofs. So our learning objectives today will be to identify roofing accessories and how they can affect longevity and durability of your roof system. We'll be describing the different types of expansion joints and what's best for your roof system. We'll discuss differential building movement and how to correctly compensate. And we'll explain the importance of edge metal systems, what works, what doesn't, and how to tell the difference. We'll start with expansion joint covers. So first of all, the NRCA defines an expansion joint cover as a structural separation between two building elements that allows free movement between the elements without damage to the roofing or waterproofing system. If you think about that, that's a pretty tall order, to be able to have different parts of the building moving against each other without damaging the cover that connects the two. Where would you find these joints? You'll find them over structural openings that are required by the structural engineers. You'll find them along the building line of building additions, points where different decks come together. Or they may change from concrete to steel or to wood, where deck panels change directions. Where the corrugations go in different directions, that'll cause your roof to expand and contract differently. You'll find them at T's, L's, or U's in the shapes of the roof, wherever you've got a break. Or you might find them for seismic expansion, and you'll find that seismic joints are particularly challenging because of the width and the movement criteria in those, and we will talk about those a little bit here. So expansion joint covers can move in any combination of movement directions. They could be thermal movement, could be seismic movement, could be wind loads, or maybe a number of other reasons. They can move horizontally, they can move vertically, they can move in shear, and they can do this all at the same time. So it's very important that you choose a cover that will provide the type of movement that is needed for your particular structure. So an expansion joint construction is basically a break in the roof section, and there's nothing in between it. So obviously water can penetrate down into your building, and you'll have all kinds of problems in there. But by putting the proper cover on it that can move in all the different multi-directions that your different roof sections are going to move in, you can shed that water out of there and keep your building dry. So an expansion joint opening is typically determined by the engineers after they have determined the governing factors such as seismic movement, wind loading, thermal movements, etc. Expansion joint covers are often specified to be able to provide a movement equal to percentage of the joint width. In other words, 50% or 100% movement. In our business, we typically provide 50% movement unless it's specified otherwise. You're talking 100% movement, you're more than likely talking about seismic activity or something along that line. So different types of expansion joint covers. You start with the shop fabricated metal. The pros of these is they're inexpensive to fabricate. They're typically fabricated by the roofer or sheet metal people that are on the job site, and they can get a quick delivery time because these guys, they're the contractors, they're the ones that are installing them, they're the ones that are making them, and they can put them on at their convenience. Cons, there's little to no tolerance for cyclical movement. They're difficult to fabricate directional change transitions. If you have a corner or a miter or something where your joint changes directions, it's very difficult to keep those sealed because you'll see an example of multi-directional movement later on here in one of the videos that we have, and you'll see how these things can move in all directions all at once. Typically, metal fabricated expansion joint covers are not warranted by the roofing manufacturer. Here's a SmackNet detail. It was made of 050 aluminum. It was placed on a machine where it went through cycles of opening and closing and the joint moving up and down and in and out. About 90 cycles, simulating about 3 months worth of activity. And you can see in here where the sheet metal had to bend in certain areas in order to allow the movement, it started to fail. Here we're actually going to show you some multi-directional movement. And you can see the machine as it's going is simulating in and out, up and down, and it's really hard to tell, but it's also doing shear movement at the same time. But it only went through a couple of cycles before this particular detail started to come apart. This is an NRCA detail made from 050 aluminum. It's a 4-inch joint with about 50% movement going on. But keep in mind that 50% movement, if the 4-inch joint is 2 inches in and out, 2 inches up and down, and 2 inches in shear, all at the same time, and it just, that sheet metal cover just wasn't able to handle all of that different movement. Extruded aluminum expansion joint covers, they have good parts and bad parts. The one that's shown here in this particular photograph can be made with a Kynar finish. So if you're looking for something that's colored, to, maybe to match something else on the roof, that might be a good thing for you to have. But keep in mind that they can be very expensive. They're difficult to fabricate directional change transitions. So if you have a lot of directional change, this may not be the way to go. They may or may not be warranted by the roofing manufacturer. Typically, your roofing manufacturers do not manufacture these, so they're coming from a different manufacturer who may offer a separate warranty of some kind on them. And they are somewhat limited in size. Pleated and compressible seals. They can be done in colors, so they're aesthetically pleasing. Some of the cons to them are they can be very expensive depending on which type you get. The pleated seals, like the one shown in the top photograph here on the left, often have multiple parts. This particular one has 4 different components to it. There's an extruded aluminum cleat on either side of the opening that has to be screwed in. So if it's a small joint, they may be difficult to get in there to do it. And there's also a rubber bladder that snaps into the back part of it, and then another one that snaps onto the front of it to make your final cover. Typically not warrantable by roofing manufacturers. You see these more often than not in vertical applications, but sometimes they show up on roofs. They certainly wouldn't be warranted by any roofing manufacturer just because of the nature of their construction. Larger sizes may have many moving parts in these things. I've seen these things wider, and they get up to 8–10 inches wide, and they have a mechanical fastener that somehow hovers in the middle. They've got crisscrossing cleats going through them to hold them in place. So they can be rather difficult. They're more for wall applications. Stretchable joint seals, you see these a lot on roofs. They have their good parts. They're low profile. They can be used in roof conditions where water needs to flow over the joint. So if you've got like a new addition next to an old addition and you're expecting the water to run from one to the other, typically these are flat in their nominal position, so water can run over them. However, sometimes they can, when the joints close, either the stretchable part of it will either sag down into the joint and collect water or bow up and cause water to pond on one side of it or the other. Now keep in mind, if water ponds down inside of it, water typically will look for a seam someplace where it'll work its way in, and then you'll have a leak. So you want to be careful of that. Anytime water can collect is not a good thing to happen on an expansion joint cover. You always want them to be shedding water. Bellows type or elastomeric expansion joint covers can often accommodate large expansion joint openings. Some manufacturers can provide factory fabricated directional change transitions. They're a cost-effective solution, and they can accommodate multi-directional movement. Some of the cons, they're not aesthetically pleasing. However, more recently, some of the manufacturers are coming out with ones that are made out of TPO and PVC to go with those respective roof membranes, and they would have a tendency to blend in with them, so the aesthetics aren't so much of an issue with those. This particular video, we're showing an elastomeric or bellows type expansion joint cover. In its nominal position, it's hard to see here, but this thing is sitting in about a half circle, so it bows up in the middle. So you can see where water wouldn't run across it if you needed it to. However, that shape does allow it to have a lot of movement in it. So if you've got proper drainage on either side of this thing, you can see the differential movement that it's taking here. This particular video is showing shear movement going back and forth. It's taking very extreme amounts, but there are conditions where that does happen. A sheet metal cover certainly wouldn't be able to handle that kind of movement for you. This particular video, if you look on the far right before it zooms in too far, you can see the bellows is actually moving inward toward that wall, whereas on the left, it's making it move and shear. It is a little bit slow, but if you have a little patience here and wait, you'll see it pop back to its neutral position before the video ends. So if you watch the left side, you'll start to see those wrinkles will start to flatten out a little bit. Here it comes now. So this is some of the differential movement that a bellows type cover can take. Imagine a sheet metal cover in a corner like this. It is not going to be able to allow this type of movement for you. Okay, so now we're going to talk about edge metal. Edge metal refers to the metal system that is typically found where roofing systems stop, such as fascias, copings, or drip edges. The edge metal is attached to the perimeter blocking, wood or metal alternative, and can be used to provide a finished and aesthetically pleasing look along the perimeter of the building. Some edge metal systems can also be used to secure the roof edge as well. So why should you use a manufactured edge metal? Well, manufactured edge metals can provide wind speed warranties from 90 to 215 miles per hour, depending on the system you're using and the manufacturer. The manufactured edge metals can meet the IBC sections 1504.5, requiring metal edge to meet ANSI SPRI ES1 certifications. Manufactured edge metal is more likely to be included in the roof manufacturer's NDL guarantees or no dollar limit guarantees. So roof manufacturers are going to be more apt to warranty or guarantee a manufactured edge metal than they are a field fabricated or shop fabricated edge metal system. So something interesting to know about edge metal systems is 0.1% of the cost of a building carries 36% of the exposure risk of litigation. So here, if your roof cost is approximately 10% of the total building cost, the perimeter edge metal is about 1% of the building cost. 60% of litigation claims originate from the roof area. 60% of roof warranty claims are attributed to metal edge failures for systems not provided by the membrane manufacturer. So by extension, out of all the litigation, 36% is attributed to the edge metal failure. So if that much of your failures are attributed to field fabricated edge metals, why would you consider anything but a manufactured edge system? So the International Building Code basically states compliance with ANSI SPRI and ES1. Section 1504.5, edge securement for low slope roofs, calls for membrane systems to have a metal edge securement with the exception of gutters. They'll be designed and installed for wind loads in accordance with Chapter 16 and tested for resistance in accordance with ANSI SPRI ES1. So that's a lot to take in, but basically what we're saying here is the IBC requires you to have an edge metal system that helps secure the roof membrane. So as you can see that every state in the United States, including Alaska and Hawaii, has adopted some form of the IBC. I do recognize, we do recognize that some states are not using the most current IBC code from 2018. They may be using older versions, but at any rate, they're still using the IBC codes, and the IBC code has always, for the last several years, has stated that it's metal securement issue. So some of the different types of metal. This is an extruded cleat fascia. You can see the silver part in the very center of the picture here is an aluminum extrusion. The pros to this type of product are that they can take significant wind load. As you recall, these things can take up to 215 miles an hour or can offer up to 215 mile an hour wind ratings, depending again on the manufacturer and of course the installation itself. They're easy to install. Most of the manufacturers have these things set up so that when you get the cleat, which would be the aluminum part again in the center of the photograph, everywhere that there's a hole, they're required to put a fastener in it. So there's no question as to how many fasteners are required or anything like that. The colors, which would be the red part in this photograph, many colors are available. Different shades. Our particular color charts, I believe, are showing something along the lines of 24 different colors that you can choose from, and there's also custom coloring available as well. A lot of times these things are used to secure the membrane, the edge of the roof membrane. We'll show you some pictures of how that works a little later on. The cons of these is they're a little bit on the expensive side. So if it's a budget job, you don't need a wind rating, this may not be the way to go. But when you do need wind ratings, this is certainly a great way to do it. This system's available for all types of roof membranes, including single plies, BURs, and mod bits. This one here is a little bit of a downgrade. It's called a formed cleat fascia. The silver part, or the cleat that actually holds it in place, is actually formed from sheet metal. It's usually a 24 or 22 gauge sheet metal that's held in place, and then there's a spring clip that attaches to it, and then the cover would go down, would snap down over it. They're cost effective. They're easy to install. There's many color options available, same as before, with the different colors and what have you. Some of the cons, lower wind speed warranties, typically not more than 120 miles an hour, again, depending on the roof manufacturer for this type of system. And these are not typically used to help secure the membrane edge. Copings, the pros of copings. They do offer many wind speed warranties, depending on the manufacturer and the system you're buying. You can get, up to 215 mile an hour warranties on these. They're easy to install. The cleats typically are spaced out every 3 to 4 feet, depending on the wind warranty. In some cases, they're continuous cleats. Again, many color options are available for the covers. Is a little bit limited, and if you've got a very, very wide wall, say your wall is 18, 20 inches wide or something like that, you're going to be more apt to want to put a fascia on that as opposed to a coping. The copings just don't come that wide. They're a little bit more expensive when you compare them to a fascia system, and they are not used to help secure the membrane edge. Other metal accessories that are available include counter flashings, gutters, brick caps, gravel stops. These are all different types of systems that are offered. There's several different manufacturers that do offer these types of accessories to go along with your roof. Some of them will be warranted, some of them will not, depending on the roof manufacturer. Gutters are starting to become more and more included into guarantees these days. Gravel stops typically are not included as guarantees, so that's kind of a low budget way to go. Okay, so we'll look at a few unintended consequences. Here we've got a shop fabricated, or excuse me, a field fabricated edge metal system where they put a, I guess a gravel stop or a field fabricated fascia in place where it dipped down into a gutter. Somebody tried to integrate everything all together here, and you can see the system is failing. If they had gone with a shop fabricated edge metal system here, they probably wouldn't be having issues like this. This is a very, very interesting photograph. On the left-hand side of the photograph, you have probably the original building that was constructed, and it had an edge metal system that was ANSI Spry, FM, and ES1 tested edge metal system on it. And the addition to the building on the right did not have, they had a field fabricated edge metal system on there. And what ended up happening was that field fabricated edge metal system failed. And as you can see, they lost not only their edge metal system, their roof membrane, their roof deck, and their wall panels as well. I imagine there was probably pretty significant damage to the components or the inventory inside of this building as well because of this. So just a very good example here of what a good, well-tested, warranted system can do for you. So perimeter nailers. So because edge metal is traditionally attached to the perimeter wood blocking, the blocking is also considered a critical part of the edge metal system. The nailer serves as the connection point between the building structure, the roofing, and the edge metal, and therefore must be designed to resist wind loading as well. Design and detail should be in accordance with ANSI Spry and ES1 and the structural engineer of record. This is not always the case. So quite often what happens is people end up with nailers that are not nailed down properly, and if the nailers aren't held in place properly, then the edge metal system is not going to be able to do its job. So here we have an example of an edge metal system. It was a field fabricated system. The edge nailer was not properly nailed down. So on the left, you can see where part of it is still in place and part of it is gone. And on the right, you can see it's as if the photographer just turned around 180 degrees and he's photographing the part of the nailer system that basically got blown off and just laid back over onto the roof because it was still attached to the roof membrane. So if you look at the fasteners in here, this is a good example of just being nowhere near enough fasteners or not the proper length fasteners to hold that blocking in place and therefore hold your edge metal system in place. Another example here where just, again, not enough fasteners. I mean, you really can't even see hardly any fasteners on the top of this thing. So as soon as the wind got underneath that thing, it just blew that whole edge right off the roof. More examples here after Hurricane Sandy in November of 2012. It's just roof blow-offs, you know, one right after another, just failures because the edge metal systems weren't able to do the jobs that they needed to do. So wood nailer alternatives, metal alternatives. The construction industries responded with some metal alternatives in place of the wood. As you can see, the top picture here is like a cleat that gets nailed down directly to the roof deck, and it allows you a little bit of a wall that rises up so that you can put insulation down on, and then your membrane would wrap over that, and your edge system would attach directly to this system. Again, you can see that it's pre-punched with holes, just like the fascia systems were. You'd be required to put a fastener in every hole, and of course, they'd have to be appropriately length fasteners. The system on the bottom is more of a sheet metal box type fastener, blocking system rather. It's a two-part system, so the two U shapes that kind of mold together. The bottom one gets nailed down, or screwed down rather, with the proper fasteners. Gets held down to the deck. The corrugated parts that you see in this photograph underneath is just the roof deck. That's nothing special. And then the top piece gets screwed down to the bottom piece through the sides, and then the insulation is built up around it. That box can be filled with insulation so that, you know, if you're trying to get a, you know, nice thermal tight fit on this thing, you've got thermal insulation in here as opposed to wood blocking or even an empty sheet metal box. And then your fascia would attach to that once the roof membrane is in place. They have proven to be much stronger than wood blocking. The alternatives, the metal alternatives will not warp and split or crack like wood does. It also does not rot. And then they're not a food source for insects or molds. And they're also not combustible. So they do have some very good points to these things. Something you might want to consider when you're doing your roof edge.